Okay, let's dig into this. Portland, Oregon, you picture rain. Yeah, lots of it.
Definitely. It's famous for it.
So how on earth is the city becoming like a surprising leader in solar energy? It feels like a total paradox.
It really does seem that way at first glance.
Today, we're doing a deep dive into some fascinating sources about rain-powered solar energy innovations. Our mission,
Hmm.
uncover how Portland is, defying expectations, maybe even using its wet climate.
And figuring out what makes solar actually viable there for you.
Exactly.
Well, what's truly groundbreaking here is how Portland's turning its biggest perceived challenge into an asset.
Okay.
Historically, yeah, you've got about 43 inches of rain annually, lots of overcast skies, conventional solar efficiency. It plummets
Right, I heard it can drop like 40 to 60%.
easily under heavy cloud cover.
Yeah.
But the aha moment isn't just adaptation, it's, well, entirely new technologies emerging.
New tech. Like what?
Think about panels that don't just use sunlight. They're also actively harvesting energy from the kinetic force of the raindrops themselves.
Wow, okay. From the rain hitting them.
Exactly. So even on a really dreary, rainy day,
Mm.
these panels can still generate maybe 10 to 25% of their capacity, which is pretty significant.
That is genuinely incredible. So what are these specific breakthroughs our deep dive uncovered? What's enabling this?
Excellent question. Our sources point to a couple of really interesting developments. First up, there's something called graphene-coated photovoltaic cells.
Graphene coated.
Yeah, research out of China. Basically, they coat these dye-sensitized solar cells with super thin graphene layers.
Uh-huh.
When raindrops hit this coating, it creates what's called a triboelectric effect. It's like generating electricity from the friction of the water falling.
Seriously. Just from the impact.
Sort of, yeah.
Yeah.
Lab tests showed voltage outputs up to 150 microvolts. Now that's small, but it's a critical extra bit, potentially boosting standard PV output by, say, 5 to 8% in the rain.
Okay, so that's one piece. What else?
And then closer to home, Oregon State University, OSU, they've been testing piezoelectric rain hybrid harvesters.
Piezoelectric. Like crystals that make electricity when you squeeze them.
Kind of.
Yeah.
These use sensors that convert the mechanical vibrations from rainfall impacts directly into electricity. OSU's trials hit 0.72 volts. It's promising for capturing that physical energy from the rain.
Wow, so it's not just about generating power from rain, but also like other functions. You mentioned OSU. Tell me about that agrivoltaicus project. That sounds fascinating.
Exactly, connects to a bigger picture. These innovations aren't just single purpose, they enable multifunctional applications.
Right.
OSU's project at the North Willamette Research and Extension Center. It's a brilliant example. They've got this 600 square foot site
Uh-huh.
where the solar panel gutters actually collect rainwater, funnel it into these big 275-gallon totes.
Okay, so water harvesting and solar.
Yep, and get this, it reduces irrigation needs for the crops underneath by 30%,
30%, while still getting power.
while still maintaining 85% crop yield. It's a powerful model, especially for Western Oregon's smaller farms.
That is seriously ingenious. But, thinking practically, what about the hurdles? Are there big barriers for those smaller farms to adopt this?
That's a fair point. The potential is huge, but yeah, the initial setup costs can definitely be a barrier for smaller operations, and you need ongoing research to really tailor the designs for different kinds of crops.
Yeah.
But the proof of concept, it's incredibly strong.
Makes sense. So beyond the cool tech, what do our sources say about the financial side for someone just looking into residential solar in Portland? What are the costs? Any weird challenges?
Well, for a home system, costs average around $3 to $3.54 watts. So a typical 6-kilowatt system, you're looking at maybe $18,000 to $21,000, and that's before federal tax credits.
Okay, still a chunk of change.
It is. But the good news for Portlanders is Portland General Electric, PGE, they offer 1.1 net metering.
Ah, that's crucial, right?
Absolutely crucial. Every kilowatt hour you send back to the grid fully offsets one you use later.
Mm.
That really helps bring the payback periods down to, well, a pretty respectable 12 to 15 years.
12 to 15 years. Okay. Any unique Portland challenges?
You might laugh, but moss.
Moss. Under
Uh-huh.
the solar panels.
You got it. You think sun, but in Portland, you got to factor in the moss. It can actually speed up roof degradation under there. Means maybe $300 to $500 a year in cleaning costs.
Wow. Okay. Didn't see that coming.
But good news on that front, too. Newer racking systems, the ones holding the panels up, they have larger gaps now, seems to be reducing moss issues by about 60%.
Moss and solar, who knew? So looking at actual data, what does a system like this deliver day to day, especially with Portland's, very varied weather?
Yeah, performance is key. One source looked at a 12.4 kilowatt-hour residential system up in North Portland. Big seasonal difference, as you'd expect.
Right.
It might generate only 4 to 8 kilowatt-hours a day during continuous winter rain,
Okay, low end.
but then jump up to 55 or 60 kilowatt-hours a day in the summer sunshine.
Big swing.
Huge swing. But the annual average worked out to about 28 kilowatt-hours today, enough to offset 92% of that household's electricity use.
92%. That's impressive.
It is. And interestingly, there's this post-storm cleaning effect. The rain actually washes off dust and pollen.
Huh. So the rain helps clean them.
It improves the yield afterwards by maybe 3 to 5%. And even freezing rain, which sounds bad, has the pretty minimal impact overall. Less than 1% capacity loss, under 2% of annual production.
That's a really comprehensive picture. So what does this all mean for the future then? How's Portland planning to build on these innovations?
Well, Portland's definitely looking ahead. There's talk of expanding their solar plus storage program to specifically include these rain harvesting hybrid systems,
Makes sense.
and maybe revising building codes to encourage agrivoltaic retrofits, making it easier to add these systems later without huge structural costs. All that, plus the research partnerships with OSU, it really positions Portland as a trailblazer.
A leader in sustainable urban energy, driven by its own climate.
It truly shows how a regional climate challenge can become this powerful catalyst for technological innovation. Portland's just a perfect example of climate adaptation driving some incredible advancements.
Absolutely fascinating. So it makes you think, as you look at your own environment, what local challenges could actually become surprising springboards for innovative solutions right where you are.